Hey there. Today what we're going to talk about is the sum of the interior angles of polygons and regular polygons. Let's get it started. First, what I want to talk about is how do we come up with the formula of finding the sum of the interior angles of any given polygon. What I mean by a polygon, again, I'm going to start with a triangle. We all know what that looks like. And what I'm looking for is I want to know what is the sum of the interior angles of a triangle. Well, let's start kind of filling out this chart. We know that it has three sides, and the number of triangles kind of within this polygon is just one. You may have already learned this, but that the sum of the interior angles of a triangle are equal to 180 degrees. I won't prove that here on this video, but I will link one here if you would like to see kind of the proof for why the sum of the interior angles of a triangle is 180. What we're going to do is continue filling out this chart. A quadrilateral is any shape with four sides. So here's an example. And what I want to know is what is the sum of the interior angles? Well, the number of sides is 4. The number of triangles that I could make. Well, I could connect these two corners, and then I'm able to create 1 and 2 triangles within this, and I can't create any more. What I don't want to do is connect across like this, and then say that there's 4. We just want to be able to, again, we can't have these interior lines crossing it all. So all we have there is 2. Next, what we have to look at is the sum of the interior angles. Well, if I already know that the triangle is 180, if I'm then looking at this first triangle, then that would give me an interior angle of 180. Here with this one, this angle, and that angle, if I add up the other triangle, that's also 180 degrees. So the total would then be 360. Let's now look at a pentagon. That's going to be a 5-sided shape. And we're looking for the interior angles. The number of sides is 5. The number of triangles I can make, well, starting from this corner, I can connect here, and I can connect there. So I have 1, 2, 3 triangles. If I'm then adding the sum of the interior angles, well, the first triangle would have 180 degrees, second triangle another 180, and the third triangle another 180. And what you can see is that all of the interior angles of this have been included. So we're going to go 180 and we're going to times that by 3, and that's going to give us 540 degrees. We can probably start to see a pattern here. So let's go with hexagon. For a hexagon, we have 1, 2, 3, 4, 5, and 6. Again, just looking at this pattern, I should be able to create 4 triangles. Let's see if I can do that. Well, I can go 1, 2, and 3. Yep, I've got 4 interior triangles, so I'll go 180 times 4, and I'm going to get 720. I'm thinking you can start to see a pattern here. What if I had an n-sided polygon? What I'm trying to now do is find the general case. So if I have n sides, how was I relating this column to this column? What we can notice is that how I'm going from 3 to 1, 4 to 2, 5 to 3, 6 to 4, is that I'm subtracting 2. If I had 6 sides in my hexagon, I was able to then create 4 triangles. So whatever sides we start with, in this case would be n, I'm going to take away 2, and that's always going to give me the number of triangles that I'm able to create. Next, what we want to look for is the relationship between this column and this column. How do I get from 1 to 180, 2 to 360, 3 to 540, 4 to 720? Well, what I was doing was I was looking at how many triangles were created, and I'm timesing that by 180 because I already knew that there was 180 degrees in every triangle. So what I'm going to do is take 180 degrees, I'm going to multiply it by n minus 2. This is going to be our formula. How you may see it written is as the following. So this is known as function notation. You may be using this. You may also just be using S to represent the sum of the interior angles. So for my formula here, n is going to be the number of sides in the polygon, and S is going to be the sum of the interior angles. Let's do a few examples using this formula. Determine the sum of the interior angles of a 20-sided polygon. This is also known as an icosaigon. If you've never looked up the rules of how they name polygons, it's actually quite interesting. I would definitely look it up. It's pretty cool. Anyway, let's get this going. We're going to start with our formula. So S equals 180 degrees times n minus 2. In this case, n is how many sides? Well, we're looking at a 20-sided polygon. So let's input 20. 20 minus 2 will give us 18. And then we're going to times that by 180. What we should get here is 6,480. So if I was to draw a 20-sided polygon all the way around, all of the interior angles, when I add them up, would add to 6,480. Let's try another example. Determine the measure of the interior angles of a regular hexagon. What we need to know is, what does it mean by regular? A regular polygon, in this case a regular hexagon, is a polygon where all of the sides are the same length. So for our hexagon, what it means is that all of the sides are the same length. This is probably the one that we're used to seeing for the most part. We don't really tend to think of hexagons as having different sided or different lengths of sides, but obviously a hexagon can. It's just a regular hexagon has all of them being the same. What that means is that all of these interior angles would also be the same. So if I have a regular shape, I'm able to find what is the individual interior angles. Let's start with our formula. So S equals 180 degrees times n minus 2. In this case, n is talking about the number of sides. Hexagon has 6. So we'll have S equals 180 degrees times 6 minus 2. 6 minus 2, of course, gives us 4. And we're going to times that by 180 degrees, and what we'll get there is 720 degrees. Since all of these interior angles are the same, I'm going to take the sum and divide it by how many angles I have. Because a hexagon has 6 sides, it also has 6 interior angles, and what we'll do is divide that by 6. And what we'll get there is 120 degrees. So each individual angle is 120 degrees. Let's try another example. The sum of the interior angles of an n-sided polygon is 2,340 degrees. Determine n. Now I know what the sum is, and I need to know how many sides does a polygon have. Let's figure this out. So again, start with our formula. S equals 180 degrees times n minus 2. In this case, I've now been given an S value. So let's plug that in. To solve for n in this case, first what we want to get rid of is the 180. So I'm going to divide both sides by 180 degrees. On the left side, what I get here is 13 when I divide. And on the right side, 180, 180 are canceling, and I'm left with n minus 2. Next, we'll add 2 to both sides, and I have 15 equals n. So meaning that this was a 15-sided polygon to begin with. Last example. The interior angle of a regular n-sided polygon is 150 degrees. Determine n. In this case, again, we have the word regular, meaning that we have a polygon where all of the sides are the same length and all of the interior angles are the same size. And what we've been told is that the interior angle is 150 degrees. So that's of one individual angle. First, we want to determine how many sides does this have. Let's start with our formula. N minus 2. What we need to do here first is think about, all right, well, 150 times n, the number of sides, would give me the full interior angles. So if one angle is 150 degrees, and I multiply that by how many sides that the polygon has, then this is equal to the sum of the interior angles. We can then replace that with S, because we know that S is also the sum of all the interior angles. So here we're going to get 150 degrees times n equals 180 degrees times n minus 2. What we need to now try to do is solve for n. Let's expand the 180 degrees through the brackets. On the left side, I'll have 150 degrees times n. On the right side, 180 times n. minus 360 degrees. Let's try to get all of the ends on one side. So I'm going to subtract 150n from both sides. And I'm also going to add 360 degrees to both sides. On the left side, those are canceling and I'm left with 360 degrees. And on the right side, 180 minus 150 is 30. Last, what I'm going to do is divide both sides by 30 degrees. And what I'm going to get here is 12. So this is from a 12-sided regular polygon. I hope this video helps you. Please let me know if you have any questions. Thank you. Bye.